स्टूडेंट्स डिस्कस करेंगे अबाउट द कॉम्पोजिट सिग्नल्स। हम लोगों ने बात की थी साइन वेव्स की, सिंपल साइन वेव्स, सिंपल एनालॉग पीरियोडिक सिग्नल्स, द सिंपल form of periodic signals. The second form of the prevalent periodic signals is the composite signals. As I told you earlier, a composite signal is made up of multiple sine waves. Students, एक simple sine wave, it's enough to propagate or to convey simple messages. It is okay for an electrical signal or to carry a power signal. It's okay to actually communicate or convey a alarm, a single alarm using a simple sine wave. However, when we talk about the advanced applications, let's suppose talking about a telephone conversation or telephone communication between two telephone sets, a single sine wave is not enough. If we try to use a single sine wave for such a communication, we will only hear buzz. So students, in this particular case, what we do is we use composite signals. The composite signals, once again, are signals that are made up of multiple sine waves. Now students, composite signals can be periodic or aperiodic. They can be repeatable patterns after a period, or they can be completely non-periodic. Students, slide pe chalenge and we'll look at an example of a composite signal. Students, in this example, as you can see, the composite signal that we have is a periodic composite signal, and it has got a certain frequency that's represented, let's say, by small f. Students, this type of signal is probably not the prevalent ones that we normally find in our data communication systems, but we can assume that this kind of a composite signal can be carrying multiple alarms, for example. Students, now if we try to decompose this composite periodic signal into its composite or into its elemental component sine waves, then this is what we get. The decomposition of the composite periodic signal into an amplitude time plot will give you three different sine waves. As you can see, the three different sine waves have got different amplitudes, and all three of them have got different frequencies. If we convert this into the frequency domain time plot now, the decomposition of the same composite periodic signal into a frequency domain time plot will give you three spikes. The first spike is frequency f and a certain amplitude. The second spike is frequency 3f and a slightly lower amplitude. And then you've got a frequency 9f with the smallest amplitude. This was the decomposition of a composite periodic signal into its decomposed or into its component sine waves.